Hi, this is Lab 4 on oscillations. First, this is just some background information, some important equations, position, velocity, update equations, net force, etc. That is important and gets used later in our code and tracker. And then speaking of tracker, initially it was important that I calibrated the length with the given 0.70 that was found in our lab video. I also set the coordinate axis to be the negative y down from the starting position, and then made sure the video delta frame rate was, or the frame delta time was correct for the video. And then from our tracker data, I made sure to get initial position information, the final time of the video, so that can be used in our while loop. And then I didn't write this in here, but I also calculated the initial velocity from our tracker data as well. And then tracker also spit out these two graphs, basically comparing your X and Y position with time. And this just basically tells you that the item, or like the mass, is oscillating, because as X is positive, Y is negative, and they both flip up and down, which makes sense. So I also did some math before we started coding. I found the period of oscillation, then used that to find the spring constant. I also knew that spring force was equal to gravitational force because the total energy would be 0, and then use that to find your final length of the spring, and then also found that initial velocity like I was talking about earlier. And using that, we crafted our code. So not shown here, but I made sure to change the mass of the ball in the code to be the right mass, updated initial position with what we found earlier, and initial velocity. And then seen here, like lines like basically 79 to 96, I changed constants around and inputted some of those equations that we saw earlier, given like what they were defined as in the code. And then we moved on to our while loop. So in our while loop, I made sure that the iteration stopped when the video stopped at 7.885 seconds. And then we also set our force of gravity to negative mg in the y direction. That makes sense. Updated your spring force, and then net force, your ball velocity update equation, your position equation, and then updated the spring with basically what we did initially, but now just putting that in the while loop. And then we also did the energy changes given what was also in that background information slide, those formulas, and then made sure to find like the delta of those formulas as well. So like the change in kinetic energy would be kinetic final minus initial, same for gravitational and spring potential energy. And then we made sure to calculate final energy, which is just all those energies added up, and change in final energy. From there, our coding gave us these graphs. We'll talk about these first two, or like the top two, in a little bit, but this bottom one is basically telling us that the change in potential of gravitational and change in potential of spring energy have a pretty high magnitude and are usually opposite of each other. So as one is positive, the other is negative. Change in kinetic has a pretty small magnitude, and change in total energy is pretty much 0 all the way through. So we also have to ask ourselves, for your model system, is the energy principle satisfied? The answer is yes. Energy is neither created nor destroyed. This is shown as like the orange line is 0, meaning like all of the energies are canceling each other out. So again, as one is positive, the other is negative, and the change in kinetic energy kind of like supplements that and reinforces that. And we can see that it's like a zero, the orange line, which is 0 all the way through. So therefore no change in energy. And then we also wanted to talk about period of isolation or oscillation, given the tracker data. So if we found the period of oscillation for the X versus T graph, it was about 1.6878 seconds. And then the period of oscillation for the Y VT graph was about 1.457. These are a little off. And the reason for that is going to be that they're like this object acting in the Y and the X are like affected by different components. So the X is mainly affected by the spring force, while the Y component is mainly affected by gravity. So therefore, those oscillations are going to be a little bit different and have like very slightly different periods of oscillation because different forces are acting on them, if that makes sense. But yes, this was my lab 4. Thank you.